I'll do a demonstration of the code and the behavior of a guided solution to the chat application project. So first off, how does it actually look in practice? You can sign in with the user. Let's just start off by registering here. We get a message that we have successfully authenticated, and then we can enter a room, and then we can send something into the room. So naturally, we can also just register with a new user here, register and enter the same room here. And let's just start broadcasting some stuff here. So you can see that there's a real-time communication between the two clients. They're both notified, and if any one of them starts entering a new room, they're still in the old room. So now they can chat inside of these two different rooms. So let's have a look at the code, right? So I have one service class here, which I call WebSockets service, and WebSockets service should only ever contain one socket connection. All of the other components, right now I only have one component because this is such a small application, you could just build it off one component. But even if you had many components, all of the communication with the server should go through the service, and the service should contain this one connection. So this is just like when you do Postman. So just like if you're in Postman here, and you start sending some messages, you would connect to the server and then you would start sending the messages. You don't disconnect and then reconnect when you send a new message. You keep the same connection running. That's why this variable here, you instantiate it in the constructor and then you just use it continuously throughout your application. So the client only has one open connection, and that is the same for every client. So inside of the app component here, I inject the service here, and then every single time I want to do something with the WebSocket connection, I just reference the WebSocket connection from in here. So all of the things that we are referencing here are the instances where we want to emit an event from the client to the server. So these are all the client intents, like we want to sign in, we want to register, we want to send a message to the room and such. But all of the communication coming the other direction from the server to the client, they are all in here. And why are they all in here? Well, because all of the communication will hit this point here on message. So we take the connection variable here, and then we say every message must reach this point. And from here on, we just call methods inside of the same class, and they will be directed based on the event type. So if I open up a browser here, so I've just opened up a browser here. So if I make some kind of random email address here with a random password and register, inside of here, we can see that every single of these messages, they should have some kind of event type. I know you can't see the event type for this, but it's because it's such a long message. But all of them must have an event type. And all of the ones with the little red arrow here is all of the traffic coming from the server to the client. And they are all being addressed by this handle event here. So it only handles server events. You could call them handle events emitted by the server. And then all of these, they're just named accordingly to the event type. This means anytime that the server says, now I want to authenticate a user from a JSON Web Token, this is always being triggered. So the server really prescribes what the client is doing. And it doesn't matter which client event was the original event that caused this one to be emitted from the server. It really doesn't matter. And if it did matter, then I would just make two separate events and then make a separate event type for them, such that I know this will only be addressed under this circumstance, which the server determines. So I want to show you just one example of the communication between the client and the server for one given client produced event, and that is the enter room here. So the client produces an event where they say, I will enter the room, and the client also supplies the room ID. So how does this one get to the server? Well, the server, of course, gets a message. So they always hit this point here if you're using Fleck. You say, okay, there's a message coming in, and then you must invoke some kind of event handler method. So the message in this instance is just text that is formatted as a JSON. So we have this JSON that says event type, I want to enter the room, and then it says that there's a room ID also. So it gets to the event handler class that is called client wants to enter room here. So because we already have a model, and this model here must correspond with whatever model we had in the front end. So this here has a room ID and it extends the base DTO. So does the model that we want to correspond with it on the server here. Of course, we're doing a server-side data validation, so we're saying that there are some requirements for the room ID, but this just becomes the data transfer object variable that we have here. So let's take a look at what the handle method does. First of all, it joins the room. So the server keeps track of all of the clients that are in the room. So the join room here just goes to our dictionaries, the dictionaries that we have up here with all the clients in the rooms and all of the rooms with the clients. So this is just to have better run times that I'm making 2 different dictionaries. And all of the different clients, they contain the class that's called WebSocket with metadata containing the connection and also containing information about whether or not they are authenticated. And then I also have another class called end user. And the end user here just contains stuff like, are they admin? What is their user ID in the database? What is their email? Stuff like that. So next up, what do we also see inside this method? Well, we see that we're sending a data transfer object to the client that has triggered the event, but we are also sending a bunch of different messages to everyone else who's in the room. So this one particular client-produced event has the server producing many server-produced events. So first of all, when a client enters the room, they want to get the past messages so you can see, okay, this is the last 5 chat messages inside of this room. One thing they also want to get is how many connections currently are in the room. So you can get the live connections to say, okay, there are 5 people in the room. And then the last thing that happens in the handle method is that we will broadcast to everyone in the room, which means we just traverse through the dictionary called room to clients. This is the dictionary up here. So every single time someone joins the room, we will just go through the dictionary and add the ID of the WebSocket to the room, such that when we want to broadcast to the room, we can just go through all of those IDs and send messages to those connections. And then where does the client application address these 2 different distinct server events? Well, they are being addressed inside of the WebSocket client service. So the server adds client to room here is produced here. And the server notifies clients in room, someone has joined room, is produced here. So this is the actual object that is responsible for having the event type that will always trigger this particular method inside of the WebSocket service. The few rules that you really should abide by when you're doing things like event-driven architecture, especially with this setup, is that everything that you're sending between the client and the server must always have an event type. If it is a server-produced event, it will always be handled inside of this class here, which means that if you want to set some data that the client application needs, then you should put that data inside of either some data container service or the same service that you're inside. You cannot take data from here and inject into a component. That becomes a big headache. Inside of the app component here, I can read from the WebSocket client service class. So all of the data that we're setting over time and changing over time, it just auto updates in the service and then the component reads from the service. All of the events produced going client to service, you can put those anywhere, but you must always use the same WebSocket connection that you opened initially inside of the service class, but you can reference that from anywhere. And regarding security, I just have a couple of methods. I have one method to generate a salt. I have one method to generate a hash. And then I have one method here to validate the JSON web token. and then I have one method here to issue a JSON Web Token. So even if I did use another API type, let's say that I want to have a REST API, I don't, but let's say I wanted to have a REST API, I could still reuse this or reuse this. Under that circumstance, I might have to actually make some middleware and some controller methods and a way of validating tokens inside of the HTTP requests. But all of the stuff with issuing tokens and the actual algorithm that verifies a token, it's the same stuff. You just have to have some API stuff on top of that is different. So if you wanted to, you could also have a different API type alongside the WebSocket API, but I don't recommend that. All of the stuff about persistence and how you store data in a database is not different from any other API type. If you've done REST APIs, then this is very familiar to you. And here, you just have a query here. So this is a normal SQL query, and then you have some parameters, and then you return some kind of model. So I just have a model here that's called message with sender email. And that's why inside of the client application, when you send a message, you also get the sender email. So of course, the persistence layer does not know about what type of API we're building. It just takes in parameters, and then it produces some C# objects, and it uses a data source. And the data source we're injecting inside of the program CS right here. So it's not different from any other API type. So this was just an explanation of the most essential parts of making a WebSocket API and a WebSocket client application. One thing I've noticed about transitioning from making a REST API to making event-driven architectures is that in the beginning you have some habits from doing request response, and the request response habits, they actually hinder your ability to learn event-driven architectures. In that regard, even though almost all developers, they start out by doing request response with a REST API, and then they move on to other API types, like maybe RPC type of APIs, maybe things like brokers, maybe things like WebSockets, and then they start learning new patterns other than request response. But the biggest hurdle for beginners doing event-driven systems is that they try to treat it as a REST API, and it is fundamentally different. I will make sure to make all of the source code here public. If you're gonna look through the code, I actually recommend starting out by looking through the client application. You see, the client application can do a lot of things with very few lines of code, which means you might get an overview of the entire system. Just by looking at the client application, you see, okay, this is where server events are handled, and the client events are produced here. So all of these classes, they are addressing the commands of the clients, and all of these methods here, they are addressing the wishes of the server. That's how it works. That's how the back and forth in event-driven systems work.